Okay, today we're going to take a look at the connection between our unit circle and our special right triangles. Alright, you were probably first introduced to your special right triangles at the end of an Algebra 1 class, maybe even in a geometry class. Alright, and you had the 45-45 right triangle, and as a reference triangle you let the two equal sides probably represent x, and your hypotenuse was x square root 2. Square root 2 times x. Alright, that allowed you then to use that special right triangle to find the sides of any 45-45 right triangle. Alright, you also had a 30-60 right triangle, of which across from the 30-degree angle you let that side be x, you let the hypotenuse be 2 times x, and then you let the side across from the 60 be x square root of 3, square root of 3 times x. And then there again, that reference triangle for that 30-60 right triangle allowed you to find the three sides anytime that you needed to. Alright, now, the concept of the special right triangle, alright, has its usefulness inside the unit circle as well. Here is your typical unit circle, okay, with some color coding there to indicate our special right triangles and where they lie. Okay, I want to make the connection to show you where these ordered pairs along the unit circle come from. Alright, they are not just random numbers, they come from these special right triangles. Oftentimes you will find a unit circle divided up like this with various colors. Alright, this blue line right here is indicating your 60-degree angle. Alright, well then if you drop a perpendicular down, you form a 30-60 right triangle. Alright, and we will use that 30-60 right triangle to show you where this ordered pair comes from. Alright, and then if you were to do the 45-degree angle, which is the red triangle right here, alright, and then again drop a perpendicular, that forms your right triangle right there, which is a 45-45 right triangle. And then for our first angle right here, the green triangle, alright, up 30 degrees, and again dropping a perpendicular creates that right triangle right there of again 30-60 right triangle. Alright, so I'm going to do a little comparison here, a little bit of math to show you where each of these ordered pairs come from. Alright, so let's get us a clean sheet of paper. And then hopefully I can get all three on the same piece of paper. Let's even maybe zoom out just a little bit. Okay, that'll make sure I'll give myself plenty of room. Alright, the first one that we're going to take a look at is just our the 30-degree angle forming that 30-60 right triangle. Okay, so nice neat drawing, because when I go to hand draw these it will not be that good probably. 30-degree angle. Okay, so the ordered pair that's along the unit circle for your 30-degree angle is the square root of 3 over 2, 1/2. Alright, if that is the point on the unit circle, then that means when I started at the origin, I had to come over a distance of square root of 3 over 2, and then I had to go up a distance of 1/2 to get that ordered pair right there. Now, with it being a unit circle, starting at the origin and going out to the edge of the circle would put that as a unit of one unit circle. Alright, so those are the lengths of those sides. Alright, now we're going to take these three sides, manipulate them so that it corresponds to this reference triangle over here. Alright, now I am going to attempt to redraw this so that we can write on it. Okay, not really drawing to scale, but about the best I can here. 30 degrees right there, 60 degrees right here, this side, square root of 3 over 2, this side 1/2, and this side 1. Okay, now, if I manipulate these three sides algebraically, alright, if I choose to multiply all three sides by the same number, I'm not going to be altering my triangle here. So if I multiply by 2, 2's cross out, multiply by 2, 2's cross out, multiplying by 2, 2 times 1, it's going to give me a 2. So I've got a 2 on this side, I have a 1 on this side, and I have a square root of 3 on this side. Okay, now comparing up here to our reference triangle, alright, if I let my side across from 30 be 1, alright, side across from 30 is 1, then that makes 2 times 1, the hypotenuse is 2, and then substituting 1 in there, the side across from the 60 would be square root of 3. Okay, so by a little bit of arithmetic, I have now shown that, that's where those three sides come from, even though originally the lengths were like square root of 3 over 2, 1/2, and 1, and it didn't necessarily look like it matched our reference triangle there with 30-60. It does. Okay, now let's do the same thing with the 45-degree angle. Okay, there's the nice, neat drawn picture of our 45-degree angle. Okay, on the unit circle, it is the ordered pair square root of 2 over 2, square root of 2 over 2. Okay, which means if I start at the origin and I go over, this distance had to be square root of 2 over 2, and then I had to go up the same distance, square root of 2 over 2, to get that ordered pair. And again, we're on a unit circle, so from the center of that circle to the outside edge would be the radius of 1. Okay, now if I, again, attempt to redraw that, okay, doing the best I can there to try to make those two sides equal. This is a 45-degree right triangle. Alright, our original sides, square root of 2 over 2, square root of 2 over 2, and then 1. Okay, now, again, I'm going to have to do some type of arithmetic to both sides, alright, or all three sides rather, in order to try to make it then fit and correspond to what our reference triangle says it should be. Okay, now I need these two sides to be the same. I want that to be square root of 2 preferably. Alright, so if I multiply both sides, all three sides by 2 over the square root of 2, alright, that's going to give me a 1 on this side. 2 over square root of 2. Alright, everything crosses out. That gives me a 1 on this side. Multiplying this by 2 over square root of 2. Everything crosses out. Gives me a 1 on this side as well. Alright, now when I multiply this by 2 over square root of 2, well, anything times 1 is going to be itself. Alright, but let's do a little bit of math here. If I start out with 2 square root of 2, I want to rationalize that. So I'm going to multiply by square root of 2 over square root of 2. That'll give me a 2 square root of 2 over 2. Alright, those two sides cross out. That is giving me an overall side on this one of square root of 2. Okay, now comparing that to our reference triangle. Alright, in my reference triangle right here, if I let x be 1, these two sides would be 1. This would be 1 times square root of 2 square root of 2. Alright, two sides are 1. 1 square root of 2 gives me a square root of 2 over there. Okay, so it definitely lays its roots in our reference triangle. Alright, now let's take a look at our last option, which would be the 60-degree angle on the unit circle. Alright, for that 60-degree angle, the ordered pair that corresponds to it is 1/2 square root of 3 over 2. Alright, which means that I had to start at the origin and go over a distance of 1/2. So this side would be 1/2. Then I had to go up square root of 3 over 2. Making that side that distance, and again starting at the origin and going to the edge of our circle is going to give us a 1 there because it is a unit circle. Okay, now I'm going to redraw the picture there. Alright, that makes this bottom angle 60 degrees, the top one 30, this side 1/2, square root of 3 over 2, and 1. Okay, now again, I want to multiply through by a number on all sides, alright, to try to then make it correspond to my reference triangle up here. I'm going to choose to multiply through by 2. Multiplying the bottom by 2, that's going to cross out, it's going to make this side 1. Multiplying this side by 2, 2's are going to cross out, that's going to make this square root of 3 for that side. And then again, multiplying by 2, 2 times 1 is going to make that side a 2. Okay, now in this reference triangle across from my 30, if I let x be 1, alright, across from my 30, x will be 1. Alright, replacing 1 times 2 is going to make the hypotenuse 2. Hypotenuse is 2 right there. Replacing with x being 1 next to the square root of 3, across from my 60, 1 square root of 3 or square root of 3. Okay, so hopefully that just kind of gives you an idea of where the points along the unit circle come from. Alright, I did it just with those 3 triangles in the first quadrant. You can do that all the way around the unit circle using your reference triangles, figuring out what you need to multiply by so that you can clearly see that, yeah, it really does fit that, the generic formulas for our reference triangles that we originally learned in that late Algebra 1 or early geometry class. Hope you found this helpful and useful, at least to determine where and why all those points are on the unit circle. Thanks for watching.